name is Abdul Halim bin Abdul Latif, currently a lecturer from University Technology Petronas. Today, I would like to present our latest invention with the title of Enhanced Extended Elastic Impedance Inversion, or EEEI, for Reservoir Petrophysical Prediction. I am the main inventor for this invention with the support of Dr. Eko Widipunomo, currently the postdoctoral in the Center for Subsurface Imaging in UTP. This technology basically is submitted for the Malaysian Technological Expo 2023 under the International Innovation Award, and we submitted this innovation under the ICT category. Okay, as a background of this invention, basically we developed this algorithm or this technology due to our depleted oil and gas reservoirs. Okay, so in order for us to develop a new one, we need to have an accurate, detailed and quantitative characterization of the reservoir itself. However, when we want to develop this based on the petroelastic model or PEM, there are two major challenges. First of all, the reservoir heterogeneity identification, and secondly, the determining of a robust reservoir model from the limited subsurface information. And due to this particular two major problems, we noticed that first of all, the well data set has a limited lateral dimension, lateral resolution, while the seismic data has problem in terms of the vertical resolution. So therefore, integrating between the well log and the seismic data become a difficult task, particularly in the limited data and the poor data quality that we have nowadays. Subsequently, the reservoir elastic properties has been routinely provided by the intelligent seismic inversion is no longer applicable and no longer accurate for the petrophysical properties prediction. In this technology, what we're going to present is that we're going to provide a new, versatile and robust petrophysical properties for the estimation for the reservoir petroelastic modeling. In this case, what we're going to do is basically we're going to move beyond the extended elastic impedance inversion by introducing a neural network methodology. We call it the enhanced extended elastic impedance inversion. Okay. So towards the end of my presentation, I'm going to demonstrate the application that we have done towards the understanding or developing the new field using the new EEI methods. Okay, so the contribution that we're going to demonstrate today in terms of the seismic petrophysical inversion, as well as the proof that the spatial distribution give us a better output compared to the previous one. Okay, so what is the EEI? Okay, so the EEI basically we incorporate using the base existing EEI technology or extended elastic impedance technology, okay, whereby the signal resolution and the dimension of seismic data is not been properly imaged previously, okay, and is also poorly correlated with the well log data set. Okay, so theoretically is that although we are able to predict the reservoir, the measurement is required further improvement. Okay, so in this technology, basically we propose a combination, okay, between the existing EEI with the integrated energy spectral constraint stochastic inversion methods or IESCSI, as well as the generalized regression neural network methods or GRNN. You can see that from our information being displayed in this particular the graph. Okay, the existing EEI on the left hand side indicate that there's poor correlation between the log data set with the inversion output, okay, from the red zone with the blue zone. And using the latest algorithms or latest technology that we developed, okay, under this particular technology, we able to prove that our EEI, the enhanced extended elastic impedance method, has a better correlation with our well log data set. Okay, so the new technology, the new algorithms, okay, been developed based on the existing EEI technology, with incorporating the neural networks, okay, the machine learning technology, inside these seismic inversion methods. We prove that, okay, from this particular innovation, the technology that we have developed allow the oil and gas companies to find a new discovery. This is the three of the example that we're able to prove at the moment. Okay, whereby we find out that the 4 meters of the thin gas reservoir, okay, whereby we see that the altitude measurement for this basically by using the EEI allow us to have a good correlation between the well with the seismic data. Okay, the second example in the middle of the in the picture over here, we show that the stacked channel oil reservoir volume of the shale distribution, okay, with the again with the good correlation between the seismic with the well data set. And the third example that we shown here, okay, with the strong velocity contrast and difficult petrophysical properties in the carbonate reservoir, again we able to prove that we shown that we have a good correlation, okay, between the two field data that are unable to have a good correlation before this between the Jintan and M1 field. Again, we show that with the correlation of data with the R2 information indicate that we have the good correlation of 0.93. Okay, so based on this new discovery, we already shown that our new technology enhanced extended elastic seismic inversion method, okay, impedance seismic inversion method, give us a better or improve output compared to the previously extended elastic impedance inversion methods. Yeah. So this particular discovery actually already been part of the patent output that we are already filing under the My IPO, and we have also published various or numerous numbers of papers, technical papers, journals, as well as presented in a number of conferences as well. That's all for me. That's all the latest innovation that we would like to present to the audience today. Thank you and